Today we'll be working on a synchronous sequential circuit design using JK flip-flops. So here's our state diagram, and this state diagram has 4 states, A, B, C, and D. First thing I'd need to do is identify if this is a Mealy or a Moore circuit. So if I look at those digits on top of the arrow, it's input/output, and as soon as I have something showing as input/output on the arrow, it means that the output is dependent on both present state A and the input 1 in this case. So this tells me that this is a Mealy machine. If this were a Moore, you'll see like in state B, the output would be inside the state because in a Moore machine, the output depends only on present state. So now we know that this is a Mealy circuit. We will write that down. And we said we have 4 states. So that means we need 2 state variables to identify those states. And we are going to call those state variables Q1 and Q0. We also look and we know we have 1 input variable. So because we have 1 bit, so 1 input, and we're going to call that input X. And then we look again, we have 2 output bits, so it means I have 2 outputs, and I'm going to call those outputs Z1 and Z0. So now I've identified my circuit, I've got my signals on the circuit. I can now create my state table. So we're just going to write state table here, and then we'll start drawing the table. And the table will have 2 main columns. The first column will be our present state, and the second column will be our next state. And next state could be when X is 0, and it could be when X is 1. And after that, we're going to go ahead and label using our state variables, Q1, Q0, on each one of those columns. So again, we have 4 states, so we're going to write them down. Present state could have been A, B, C, or D. And then for each one of those states, we're going to look at the state diagram and start figuring out. So if I'm in state A and my input is a 0, I go back to state A and my output is 0, 0. So I'm going to go ahead in the table and write down that my next state for X is 0 is A with my output is 0, 0. Then I'll go up to state A again and look at what happens when my input becomes a 1. And when my input becomes a 1, it takes me to state B and my output is 0, 0. So let's not forget that this is a Mealy circuit because that makes a distinction on how we write out our state table. So we're going to look at B for the next state, and we're going to see that when X is 0, we go to state A with an output of 0, 1. And when I'm in state B and input is a 1, I go to state C with an output 0, 0. Then I do the same for state C. If I'm in state C and the input is a 0, it takes me back to state A with an output 0, 1. And if I'm in state C when my input X is a 1, I go to state D with an output of 1, 0. Finally, state D. When I'm in state D and I get input X is a 0, it takes me back to state A with an output of 0, 1. And if I get X is a 1, I stay in D with an output of 1, 0. So next I have to make a decision on my state assignments because I can't design this circuit with state variables, so I have to have 1s and 0s. So the easiest way to make your state assignments is to make it resemble a Carnot map, a K-map. That makes life so much easier. So that means we're going to say A is 0, 0, B is 0, 1, C is 1, 1, and D is 1, 0. And you'll see later on why that is beneficial. It just makes life so much easier. You can then copy straight from the state table into the K-map, and your life becomes so much more simple than doing it the other way. So here I've just rewritten the state table with the state assignment because now we need to figure out what our values are, our inputs are. But before that, we need to first create the state table using the state assignments we just decided on. So it's really just a direct substitution. So I'm going to rewrite this table here. And all I do is I do a direct substitution. If there's an A, I put a 0, 0. If there's a B, I put 0, 1. If there's a C, I put 1, 1. And if there's a D, I put 1, 0. So we're just going to complete this table right here very quickly. Now it's time to consider the JK flip-flop that we were told we had to use. So I write down the excitation table, which is when JK is 0, 0, my next state is Q. It stays the same. When it's 0, 1, I get a 0. 1, 0 is a 1, and 1, 1 toggles, so it gives me Q bar. So Q is a hold, 0 is a reset, 1 is a set, and Q bar is a toggle. So we're going to go ahead and redraw this excitation table because we need to look at it in a different way. We need to look at it as present state to next state. What input on JK makes this transition happen? Because our state table gives us present to next state. So that's what we're trying to figure out. So for the JK being 4 combinations, present state could have been a 0. So we put 4 zeros in the combinations of JK, and it also could have been a 1. And if present state was a 1, you also have 4 combinations on JK. So now using the JK excitation, the original one, we'll fill in this second expanded table. So we look at present state is 0, JK is 0, 0. We know that tells us to hold, so our next state will be 0. We know that 0, 1 on JK resets, so we're going to go ahead and put a 0 there. 1, 0 sets, so we're going to put a 1 there. And 1, 1 toggles. So if my present state was a 0, it will then become a 1, and we'll put that there. So the same will happen with the second half, and we'll put 1, 0, 1, 0, because the last one is 1, 1, so it toggles from present state 1 to next state 0. Now looking at this table, it's a bit confusing because you have 2 present state zeros and 2 next state zeros. So we're going to have to now shrink this table. I know it sounds weird. You expand and then shrink, but that's what we have to do. Now you can memorize the final table we're going to get, but I like to usually create it from scratch. So we're going to redraw this table, and now we're going to try and shrink it. And we shrink it based on the present state, next state. So we have present state 0 to next state 0. We look at J and it's constant at 0, so we put down 0. And if we look at K, it doesn't matter if it's a 0 or a 1, so we put it down as don't care. Then we look at the next combination, which would be if present state is 0 and next state is a 1, which is the next 2 rows. And then we put that down in our new table. And then we'll say, okay, well, J is constant at 1, so we'll put it down. And again, K doesn't matter, so we don't care. Then we look at 1, 0. Present state 1, next state 0, we'll see that in this case, J doesn't matter and K is constant at 1. So we put a don't care 1. And then finally 1, 1, present state 1 to next state 1. We see that J also doesn't matter, but K is constant at 0. So we put a don't care 0 there. And this then becomes our excitation table that provides the JK values. If we look at it present state to next state, what input on JK makes it happen. Now you could memorize this table, this last table, or you can create it from scratch like I just showed you. So the next step is now to look at this state table that we have and create our JKs using the newly created excitation table for JK. So we draw 2 more columns. For x is 0, x is 1, I could have J1, K1, J0, K0 for either one of those situations. So I put those down. which means I have 4 columns for x is 0, 4 columns for x is 1. And then I look at present state for Q1, next state for Q1 when x is 0, and next state for Q1 when x is a 1. And then I use those and use the excitation table we created to get J1, K1 for x is 0, J1, K1 for x is 1. So now I'll look at that first column. When present state Q1 is 0, it goes to next state Q1 is 0 and x is 0. I go down to the table on the bottom and I say, okay, present state 0 to next state 0. 0 don't care on JK will make that transition happen, so I put it down. Then I'll go and look at the x is 1 column. So for the same present state 0, I look for x is 1. The next state is also a 0. So if the next state is also a 0, it means my J1, K1 for x is 1 is also 0, don't care. Now I'll go down to the second row, and I will see that present state Q1 is a 0. For x is 0, next state is a 0, which means, again, I have 0, don't care. And then I look for the x is 1. It says 0, 1. So I go down to the table, and I see that present state 0 to next state 1 gives me a 1, don't care. So I put a 1, don't care. Then I go to the next row, and present state is 1 to next state 0. That gives me a don't care 1. And then for x is a 1, it's a 1 to 1, which is a don't care 0 from the lower table. Now I go to the final row, and it's a present state 1 to next state 0, which means my JK are don't care 1. And then for x is 1, it's a present state 1 to next state 1, which is a don't care 0. And I follow the same for the J0, K0 for x is 0 and J0, K0 for x is 1. So present state 0 to 0. Now I'm looking at column Q0 is a 0, don't care. 0 to 1 for x is a 1 is a 1, don't care. Next we go from 1 to 0, which is a don't care 1. And then for x is 1 is a 1 to 1, which is a don't care 0. And then the row after that, we go from 1 to 0 for Q0 with x is 0, so it's a don't care 1. And then a 1 to 0 for x is 1, which is a don't care 1. And then last, 0 to 0 is a 0 don't care. And then 0 to 0 again is another 0 don't care. Now that we have completed this table, it's time to put those JKs into a K-map. So we need 3 variable K-maps because we have 2 state variables and 1 external input. So to get the number variable K-map, it's the number of state variables plus the number of external inputs. We have Z1, Z0 as the outputs, and then we have J1, K1, J0, K0, so we need 6 K-maps. So the first K-map we'll draw, we'll look at it, we make it look exactly like the table up top. So we have X, for this is the map for J1, we have X on the top and Q1, Q0 on the bottom. And the way the K-map is laid out, it's actually in the same order as our states that we decided on earlier. And X is 0 to 1. And we're going to draw the rest of them. And now what we do is we basically copy the red columns straight into the J1, K1 because it's laid out exactly like this K-map. So for x is 0 for J1, you have 0, 0, don't care, don't care. And for x is 1, we look at that column and the inputs are 0, 1, don't care, don't care. And then we look at K1, and then again for x is 0, we have don't care, 1, 1. And for x is a 1, we have don't care, 0, 0. We then move on to J0, and for J0 when x is a 0, we have 0, don't care, 0. And then when x is a 1, we have 1, don't care, 0. And then last of the JK inputs, K0, we have 0, 1, 1, don't care. And then we have X, don't care, 0, 1, don't care. Now we still have to do the Z1, Z0 output, so we go to the beginning of the state table and look at those and just copy them straight through. So you'll see that those will be the inputs for Z1, and these will be the inputs for Z0. Now the next step is to group. So we look at J1, we'll group the one with the don't care, and that is going to give us J1 is equal to X and Q0. And the reason we say Q0 is because when we look on the side, we see that Q1 is changing, so we throw it out. Q0 stays constant at a 1, so we keep it at Q0. So remember, you always throw out what's changing and keep what's constant. So now we look at K1 and we group the group of 4. Remember, the more the merrier. So that group of 4, we go to the top and we see X doesn't change and it stays at 0, so it's X bar. And if we look to the side, everything changes across the cells, so we throw them out. Next we do J0, we group those two on the top, and we look above and X doesn't change, it stays at 1, so it's X. And then to the side, Q1 stays constant at 0, so it's Q1 bar, and Q0 changes, so we throw it out. Then we move on to K0, we take that column, and then we also take the 4 at the bottom. Let's just fill in those combinations in there. So if we look to the top of the column, we see that X doesn't change and it stays constant at 0, so that's X bar, and Q1, Q0 change throughout the cells, so we throw them out. Then we put an OR because we're grouping the ones, and then we look at the bottom group, and that X is changing, we throw it out, and we go to the side. Q1 is constant at a 1, so we keep it at a Q1, and we throw out Q0 because it's changing. Then we will move on to Z1, Z0, and we have the two ones that are in the bottom right-hand corner. We're going to group those for Z1, and that gives us a X because it doesn't change, and a Q1 because Q1 is constant at 1. Now Z0, we have two groups of two ones there. So we look at the first group and we see that X doesn't change, it stays 0, so it's X bar. And we go to the side, we see that Q0 doesn't change, it stays at 1, so it's Q0. And then the next group, again, X bar, and this time it's Q1 that stays constant. And now we have all our equations and we are ready to build our circuit. Now that we have these equations, we know we have two flip-flops, so we're going to just go ahead and draw those two flip-flops. And they both have JK inputs, so we'll put those down. We'll usually put the J1, the flip-flop 1 on the top, and the flip-flop 0 on the bottom. And we'll also add the Q1, Q1 bar, and Q0, Q0 bar, which is the output and the inverted output for those flip-flops. And then first thing we connect is the clock, because that's what makes it a synchronous sequential circuit. So now we just need to try and draw these lines for Q1, Q1 bar, Q0, and Q0 bar. And what I do here is I try and pull those outputs up, across, and then down. So then when you're building your circuit for the J1, K1, J0, K0, you're just pulling from the lines in the front and then connecting them. So we'll just go through and draw all these lines up, across, and down. So then you have your input lines right in front of the circuit. I'm just going to redraw those on a little bit higher up so that we can have our space. And now we need the X input because we have one external input. So we're going to draw that right there and give it an inverter because in some cases we have an X bar that we need. So now we're ready to build the circuit. And J1 is an XQ0, that's an AND gate. So we're going to draw that there. And it takes in X input and then it also takes in a Q0. And see how easy that becomes? We just pull straight lines out of the input set. K1 is a X bar, so all we have to do there is take a straight line to X bar. Then we go to J0, and that's XQ1 bar. Again, it's an AND gate, so we're going to draw an AND gate right here. And then the inputs to that are X and Q1 bar. K0 is a bit different. It's an OR gate because it's X bar or Q1. So we draw an OR gate and we take one input to X bar and the other input to Q1. So now we need to build the Z1, Z0 output, and unfortunately I did not give myself enough space to do that. So we're going to start by drawing Z0 first. And Z0 is an OR gate with two AND gates going in. So we're going to draw the OR gate first, and then we have the two AND gates. So we're going to draw those. The first AND gate takes in X bar and Q0, and the second one takes in X bar and Q1. So we need to draw these lines, and unfortunately I don't have the right space over here on the circuit. You really need more space when you're drawing these things, so we're just going to take a line straight from there for X bar. And since it's going to both gates, we're just going to connect them together. And then Q0 goes all the way to Q0 and connects with it. And Q1 goes all the way to Q1 and connects to it. And I apologize for the mess that's on this circuit right now. But when you have a larger piece of paper, you'd be able to draw this better. So now we build Z1. And that is an AND gate that takes in X and Q1. So we're just going to write X and Q1 on those lines. And then we take the X and connect it to the X input and take the Q1 and connect it to the Q1 input. And that completes the design of this circuit. So those are all the steps that you needed to take to actually design a synchronous sequential circuit that implemented the state diagram given at the beginning using JK flip-flops.